Hi guys, this is Tobias DL3MHT with another experiment with the switching power supply. This time I hooked it up to the TinySA, suggestion from Bob from the European HamRadio show, so thanks for that. The only problem I have is that the TinySA is spec'd to start measuring accurately starting with 100 kilohertz, and I guess our switching frequency is lower. So the result here is probably not correct in terms of the dBm it shows, but I hope the frequency at least is correct. So at the moment the power supply is switched off and I've set the scanning to scan from, let me see, 10 kilohertz up to 150 kilohertz. And I think averaging times 4 is switched on to get a bit less noise on the display. So let me switch on now. No load connected. So that's just the power supply set to 13.8 volt. And as you can see, we already see the spikes climbing up slowly. So we see one around 32 kilohertz and maybe the second one is a little bit lower, then the third and the fourth is also visible. So let me wait a bit for it to stabilize and then we hook up the 1 ohm 100 watt resistor again and see if anything changes in terms of, well, the spikes we see here. I think it has stabilized now, so let me connect the resistor. Okay, it's cooled down from the last attempt. And as you can see, the second spike, harmonic, I don't know how you could call it, is climbing up here slowly. And also maybe the third one is a bit higher. And has it stabilized again? I think it has. So we can try to freeze the trace now and disconnect my resistor again. And then I will zoom in a bit, move the camera to show you the display in a bigger size. Okay, and here we are zoomed in a bit so that you could see the 4 spikes I'm catching a bit bigger on the screen. So you can pause the video and have a closer look. I'm continuing now with checking if the noise offset knob of the power supply has any effect. Okay, and as you can see, to save some time, I've already took 2 traces. So the yellow one is with the noise offset set to a minimum and the green one with the noise offset set to the maximum. And I've picked the 32, 34, 36 kilohertz spike here. So the middle seems to be around 34 kilohertz. When you set the noise offset to the middle position, when you turn it all to the left, we are somewhere around, I don't know, 32.5, maybe 33 kilohertz. And if you turn it all the way up to the right, you're probably somewhere near, I don't know, 35.5 or 36 kilohertz. So as you can see, you can indeed shift the switching frequency a little bit to avoid that one of these harmonics ends up directly on your receive frequency. Okay, so I think that's it for the moment with this video. Thanks for watching and until next time. Bye.